Miguel is a recent law school graduate who intends to take the state bar exam. According to the National Conference on Bar Examiners, about 57% of all people who take the state bar exam pass. Let X represent the number of times a person takes the bar exam until they first pass. We're asked to A, write out a formula for the probability distribution of the random variable X. B, what is the probability that Miguel first passes the bar exam on the second try? C, what is the probability that Miguel needs 3 attempts to pass the bar exam? D, what is the probability that Miguel needs more than 3 attempts to pass the bar exam? Okay, so for A here, we need to basically write out identify P and Q because our formula for the probability distribution is given in terms of those values. In fact, what we need to compute here is the probability of X, or excuse me, to write the formula, we need to write P, Q raised to the X minus 1 power. Okay, so we need to identify P and Q. And so we could see from this a successful outcome is passing the bar exam in a single attempt. And so we are told that probability of passing the bar exam in a single attempt is 57%, or 0.57 as a decimal. Q, which is the probability of not passing the bar exam in a single attempt, is just 1 minus P. And so that will give us 1 minus 0.57, which is 43%, or as a decimal, 0.43. Okay, so P is 0.43. All right, so now we could fill out our write out the probability distribution, which in this case is just the geometric distribution. Now there's a geometric distribution models this particular situation. So we have 0.57 times 0.43 raised to the X minus 1. And that there is our geometric distribution that models this problem. Okay, so B, what is the probability that Miguel first passes the bar exam in the second try, in other words, the second attempt? That just means we're looking for the probability that X equals 2. And here, we could use the formula if we want. It's not too hard to do it, but here I'm going to show you how to use this calculator that I've given to you. And so here I'm calling this the geometric calculator. The way it works is you have to provide it a value for P. So in this case, we would provide it the value 53, or excuse me, 57, since that's the probability of success. And then we are asked to find the probability that X is equal to 2. Okay, so there's 2 ways to do this. The first way I'm going to show you is just putting in the value 2 here. And since we want the probability that X equals this value, then we would look right here. And so the probability of that would be just 0.24510. Okay. Alternatively, you could generate a geometric probability distribution table by specifying the number of rows you need. The random variables associated to this particular scenario that can be modeled by a geometric distribution is a countable random variable. So technically the table doesn't end, but we can only generate 1,000 values here. So I'm going to just generate 20 of them just to show you what I mean. Okay, so it keeps on going on, but after a while you'll start to see that basically probability of 0 will start appearing because it's very hard to not get an attempt if you take it many times, okay, or have so many trials. So in this case, the probability that X equals 2, reading off from the table, would be just this value here that corresponds to X2. Okay, so you can see these two values agree. All right, so we could see then the probability that X equals 2 is 0.245100. Okay, in other words, there's about a 24.5% chance that Miguel will pass the bar exam in his second attempt. All right, C here. What is the probability that Miguel needs 3 attempts to pass the bar exam? Very like this, like the previous case, x equals this time 3. Because we're saying what's the probability of him passing in 3 attempts? So likewise, we could either specify the 3 here, hit enter, and then get this as the probability, since that's the probability that x equals 3. Or you could read off from the table that x equals 3, and you could put here whatever that value is. Okay, so that's the value. So the probability that x equals 3 is just that. All right. D, what is the probability that Miguel needs more than 3 attempts to pass the bar exam? So more than 3 translates to x greater than 3, which is equal to the probability that x is either 4 plus the probability that x is 5, or plus the probability that x is 6, plus, dot, 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 dot. Okay, so in cases like this, if you're doing this by hand, you would rather use the complement to do this and think of this as the probability of x greater than 3 is the same as the probability of 1 minus the probability that x is less than or equal to 3. That's the complement rule. And this way you don't have to add things forever. You just simply go 1 minus the probability of x less than or equal to 3. Now, of course, the calculator gives this number for us pretty easily by just specifying 3 here. And since we're looking for the probability that x is more than 3 or greater than 3, we would take this value here in row 16 in cell B16. And that's the probability of x being more than 3. So there's about a 8% chance or 7.95% chance of Miguel passing in, say, attempt 4, 5, 6, or some later attempt.